Hey Jake, this is 3-4. We're going to start with one-sided limits. We'll see how far we get today. They're talking about continuity, which means continuous functions. Okay? Continuous. Okay? All right, most functions are continuous. Every polynomial function is continuous. When you start to get funny business, like rational functions in there, is when he is not continuous. So I'm going to talk about not continuous things. Not continuous. What can happen for a function to not be continuous?
It's not rational function.
It's like a rational function, but like what does rational functions have?
Holes.
Like what we're holes, right? Okay, so he could have a hole. What else could he have?
Aha.
An end.
Aha is not going to make him not continuous though, because ha's affect the y coordinate, not the x coordinate. What? What about a piecewise function? Okay, let me show you what a piecewise function is. Piecewise function is like this guy, where he has two different pieces and they do not meet each other, which causes a
Are you watching TikTok?
jump. Shh. Piecewise functions which cause jumps in your graph, right? So we have holes, we have vas, we have piecewise functions that make jumps in the graph. Those can cause a function to not be continuous, yeah? Okay, we want to evaluate limits at those funky, weird places where things, like weird things are happening. Like at holes, I want to evaluate the y coordinate. If there was a y coordinate at that hole, I want to know what it is, right? So here's some things. Like this guy, f of c or f, the y coordinate is not defined. I'm going to say no y coordinate at this point, but will this point have a limit? Yes, he will have a limit. Yes, limit. Okay, this dot right there, it is a hole, but if I filled him in, he would have a definite y coordinate, yeah? Okay, let's go to the middle one. So he doesn't have a y coordinate, but he does have a limit, all right? Here, if I'm looking at this place, does he have a y coordinate?
In theory.
He does have a y coordinate. What is the y coordinate? Whatever this dot is right here, right?
Back.
Like he's filled in there. Does this place have a limit?
No, yeah.
I give it.
No,
Okay, now hold on a second.
limit does not exist.
Why does the limit not exist?
Because it's right there.
Because
What?
he still says y.
What?
Or he still has like.
Because the two lines on the opposite sides are not
Alright.
close at all.
Yeah, so like we say, like, okay, if there was a y coordinate, what should it be? This side is telling me the y coordinate should be that dot. This side is telling me the y coordinate should be that dot. So which one do we go with?
Because C
Does
plus
not
and
exist,
C minus
right?
do not exist.
So
They
this
do not
one-
connect.
Yes, he does have a y coordinate, but he technically doesn't have a limit because the two sides are conflicting with each other, right? That's what a piecewise function does sometimes, okay? Good?
Why are you doing that?
Let's go to the third one.
Okay.
Does, at this place, do I have a y coordinate?
Yes.
Do I have a y coordinate?
Yes, you do have a y
Yes,
coordinate.
where is it located? Whatever this guy is right here, right? Does he have a limit?
Nope. Yes, he does have a limit. No, because there's the dot there.
It's just fake.
I do not get this.
He does have a limit.
He does have a limit on the left side. It's telling me if I'm just following the lines of the graph into that point. If I follow, ignore this dot right here. If I follow the lines of the graph in, it's telling me the y coordinate should be here. This side is telling me the y coordinate should be here. So, had this dot not been here, the y coordinate should be at this spot. That's what the limit is. Right? The limit is what the y coordinate should be. The limit is what the y coordinate should be, yeah?
I do
Okay.
not get it, but it's fine. Keep going.
Okay.
So the limit does not exist if each side is approaching something different.
Correct. The limit does not exist right here because they're approaching something different, right? Here, both sides are approaching the same value. Even though it's not actually where the y coordinate lives, the limit is what it should be, right? It should be along that line. It should be where that open circle is filled in, or is not filled in, right? Okay, so you can have yes a y coordinate, yes a limit. You can have yes a y coordinate but no limit. Ooh, let me go back. Yes a y coordinate but no limit, okay? And then you can have no y coordinate but yes limit, right? That's how that works. Okay, we're gonna talk about, let's go down here. Discuss the continuity of each function. Things fail to be continuous where domain errors occur. Will we have a domain problem
Yes.
on number one?
Yep.
Where?
0.
At 0. X can't be 0. That's how I'm going to define or discuss the continuity. It's not continuous at 0. right? Not continuous at 0. You can write that in there. Not continuous at 0. Okay, because x can't be 0, so not continuous at 0. Yeah? Because there's a va there, right? He has a problem. Discuss the continuity of each function. Alright? 2. Will he have a problem?
Yes.
Yes.
What will he have?
He can't be 1.
X can't be 1. Okay, what's occurring there?
A hole.
Is it a hole or a va?
If they cross out, isn't it a hole?
Yes. How do you know they cross out?
Because that's a difference of squares.
This is a difference of squares. Okay, so it is x plus 1 and x minus 1, right? So x minus 1 cancels out, right? So this is actually a hole at 1, okay? And what they will call that, write this down and put a star by it, they will call that a removable discontinuity at 1. Because I was able to remove it, right? I was able to get rid of it. Like I deleted it out after I factored it, right?
How is
If
it
I
1
put
and not
discount,
a
it's
negative
because you
1?
did not
Because
spell
you
out
set it
discount.
equal to 0. So
Okay.
x minus 1 you set equal to 0 and it's actually a positive 1.
So
I'm gonna
it is
go up
still the ones that
in
cross
like
out.
Yes, it's
holes
still
and
ones
be
that cross
like,
out, but it's after you set
Is
it
there
equal
a
to 0. Good question.
discontinuity on this sweater here? Is there a 30% discontinuity?
Okay, let's go over to this first one. Number 1 that we just did, is this a removable or non-removable discontinuity?
What
Why
does that
why
mean?
is it non-removable?
It doesn't
Because-
cancel.
I can't get rid of it. There's nothing I can do to get rid of that x. Here, I was able to delete it out. I was able to get rid of that, factor it out, and then I could evaluate the limit, right? Like what we did yesterday. I can plug numbers in now that I've made them gone. So this is what's called a non-removable. Non-removable.
That's
Yeah?
mega confusing.
Mega confusing.
Is this the part where Mallory cried last year?
No, I don't know.
Actually, never mind, because I'm pretty sure that was like a lot of times. She got really stressed out about
All right, number 3. This might be a
Okay.
confusing one.
this.
Okay, let's see what 4 does. Yeah, number 3. Okay, this one is a piecewise function. Here's how piecewise functions operate. Piecewise functions operate. Okay. All right, this is where we talk about one-sided limits. That's the title of this section, is talking about one-sided limits. Okay. So what we're gonna do is 0 is the point that's in question, right? If they're gonna have a jump, it's gonna be at 0. Does that make sense? Okay.
But it
So
doesn't.
what we're gonna do
Perfect.
is 0, we're gonna come in from the left side and we're gonna come in from the right side and we're gonna see what the y coordinates should be on each one, okay?
One.
So here's the deal. On the left side, you gotta listen to this. Shh. On the left side is gonna be this function. How do I know that's gonna be the left side?
Because if you're pointing left.
Because it's less than 0, right? Less than 0 means on the left side of 0, yeah? Okay?
Alright,
If I plug 0 in,
It's the same thing.
if I plug 0 in, this dot right here is at 0 comma what?
1.
1. Yeah?
Huh.
Okay? Now, if I'm coming in from the right, which is this function right here, greater than 0, and I find that dot is 0 comma what?
1.
1. So are those dots going to touch each other, or is there going to be a jump?
Touch.
Yeah, touch.
Like they're going to come here, and I'm going to have an open circle and a closed circle, and they're going to go like this, right? Instead of the normal piecewise function where I have this going on, right? It's going to be like this, and it's not going to be like this. That's not what's happening. Do you see that? Because the left and the right side have the same y coordinate, right? When I plug 0 in, I get the same number here as I did here. So, when it says discuss the continuity of this function,
Continuous.
it's continuous. It's continuous on all reals. It's gonna touch everywhere because my circle is filled in. I'm gonna not have any jumps, right? When do you have a jump on a piecewise function?
When the
When
y's
it's-
are.
When the y's would be different, right? You would have a jump that looks like this, right? Does that make sense?
Yeah.
Yeah?
No,
That makes sense?
but-
You just plug in that
For the
number they
most
have.
part.
The number that they have, because that's where there's going to be a problem if there was one, right? This one doesn't have a
What if
problem because when I
they're
plugged it into the frame, that's when it's not continuous. So you would say not continuous at x equals 0 or whatever, right? Or x is not equal to 0.
Well, if they're different numbers, but you get the same thing.
They won't give you different numbers here because they have to tell you like where it switches over. Does that make sense? Yeah, those have to be the same number. Number 4, x squared. Discuss the continuity of the function.
It's
All real.
Continuous,
continuous.
it has no domain errors. It's continuous everywhere. Continuous on all reals. He has no jumps, no skips, no vertical asymptotes, no holes, no nothing, right? So the three things that we talked about up above here that would make a function not continuous were holes, VAs, and piecewise functions. Check it out. We had an example of a VA. We had an example of a hole. We had an example of a piecewise function. Oh, right here. Piecewise. Those are the three things that are going to happen that makes a function not continuous.
And we're gonna be down from the
VAs, holes, piecewise functions. If it's just a normal function like x squared, he's going to be continuous everywhere, right? So if it's anything other than a VA, a hole, or a piecewise function that has a jump, he's going to be continuous everywhere. Make sense?
Very much so.
Okay, let's do one more thing on the next page. Maybe.
I don't really want to.
Let's do.
No. We'll wait till tomorrow.
No, I
Yeah.
like this. I like
No.
this. We'll do the next two examples because they're really good, and then
The
we'll wait.
next two?
We'll wait on the box. We'll wait after the box. Okay.
That's a
Here we go.
lot.
We're talking about limits from the left and limits from the right. Okay. I don't know if you caught that on the front side, but the limits from the right and limits from the left. I've used this notation before, where it says like the plus sign. That means from the right, right? If it's like the limit as x goes to 2 plus, that means coming in on the right side of 2. Okay? That's that notation that they will use. Alright? The top of the next page says, like, let's say I would say x going into 2 minus. That means coming in to the x coordinate of 2, but on the left side, right?
What?
Okay? I'll show you
So
the
the
picture.
left to the right, not from the right?
From the right and from the left.
So going left.
Okay, so let me give you an example. Well, I'll use the value of 2 also, okay? So let's say 2 is here, right? And let's say we'll go 1, 2, 3 here. I'm gonna say a closed circle and we're gonna go like this. And we're gonna say an open circle and we're gonna go like this, right? Okay? There's my function. I have no idea what that function is, but I just did a graph of it, okay? Let's find the limit as x goes to 2 plus and the limit as x goes to 2 minus. Okay? 2 plus means coming in on the right side. 2 plus means coming in on the right side. So on the right side of the graph, on the right side, that's gonna follow along this loop. What should that y coordinate be coming on the right side?
1.
1. Yeah?
Yeah.
Coming in 2 minus on the left side, that y coordinate should be
3.
3. Okay, now what if I throw this in there and I say what's the limit just as x goes to 2?
So plus.
2.
Oh, it's both.
The limit
sides.
as x goes to 2 is coming in on the right side and the left side. So is it 1 or is it 3?
Oh, 2. Average.
It's non-existent.
Does not exist. They're conflicting with each other, so you don't have to decide. You just put it. The limit doesn't exist. If they're going to 2 different places, you don't have to decide. The limit doesn't exist. There is no limit because we don't know what the y coordinate should be. They're arguing with each other, right? That's how that works. So left and right-handed limits, yeah? Okay, so let's talk about this one right here. They have this graph right here. This is my function that I have, okay? And they've graphed it here. It's a half circle, really, is what it is. It's kind of cool. They're saying find the limit
I used to draw
as
this in
it
class,
approaches
so I could
negative
do
2
some.
from the right, okay? So as x goes to negative 2 from the right side is plus, okay? Negative 2 is right here. This is where negative 2 is. And we're coming in from the right side. Why would they say the right side rather than just negative 2 in general?
Because well, I'm coming in this way.
What if we're going this way? We have nothing over here, right? So we can't find the limit of just negative 2 because he has nothing over here to like me even ask, right? Do you see how that works? He has nothing to the left side of negative 2. I can't evaluate it on the left side of negative 2 because I only have this stuff right here. What would the y coordinate be as it comes into negative 2 on the right side?
0.
0. You see that? This y coordinate right here is 0. Do you see that? But do you see why we're only looking at the right side of it? He doesn't have anything on the left of negative 2.
Well, yeah,
Yeah?
I
Okay.
guess.
Okay? Now let's go down to this one. This will be the last one and then we'll stop. Okay? This is the greatest integer function, which looks like this. It's that step function, right? It's like how old are you on that day, right? So if you're 16 years and 4 months, you're still only 16 years old until your birthday and then you bump up to 17, right? Like that's how that works, right? That's what a step function looks like, okay? Or a greatest integer function looks like.
Yeah.
So they're asking us to evaluate this function as we're coming into 0 from the left side, okay? 0 lives here. This is where 0 lives on the x-axis. As we're coming in on the right side, what would the y coordinate be on the right side of 0?
Wait, I thought it was left.
Oh, left side, I'm sorry, left side.
Oops.
That's what I mean. would follow the function, oop, it's gonna stop right here, this coordinate right here should be -1. So on the left side of 0, it should be -1, right? Okay, what should the y coordinate be on the right side of 0?
No.
0.
0.
0, right? You see that dot? He's coming in right here.
No.
This is the little
Yeah.
piece that you're gonna look at. So that's y coordinate of 0, right? So what if they said the limit as x goes to 0, just plain 0?
Just from
Left and right
both sides.
together.
No, do
Oh,
not exist.
Does not exist because these two numbers are not the same. Do you see how that works?
Yes.
Yes, okay? On the left side it's touching -1, on the right side it's touching 0, yeah? And the fact that those two have a jump in the middle means the limit does not exist.
So
Got it?
basically, you find the number it's talking about, say it's 0,
Uh-huh,
and then it's negative, so you just find the line going that way, and
Yep.
then go to that line.
Yep. that's exactly what you do. Yep,
Is this what we do for the rest
Good.
of the
that's what we're doing for the rest of the thing,
What are you doing?
okay? Alright, we'll finish the notes tomorrow, but I would start on the homework so that you can like get that information down. Some of these are like really super quick to just do, okay?
No, I don't.
You have a question already?
No, she just don't.
Wait, but it's not giving you a number of these.
Yeah.
On number 1, they
Yeah,
say
it's just
C
saying-
is 3, so this is 3 plus, this is 3
Oh, I
minus,
see it,
this is
see
3,
it, I see it.
right, you see it?
So
I got
you
number 1.
can't- So would that one be non-existent because you don't know which way it's cut? No, because they're both. It'd be non-existent because
On the right side of 3, what's it going toward?
0.
It's going toward a y coordinate of 0. Even though it's evaluated at 1, right? The y coordinate's actually at 1. What should it be? It should be at 0. What's the limit as it comes in from the left side?
0.
0. So what's the limit both sides together?
0.
0, right? They're touching each other. There's no like discontinuity there, right? Does that make sense?
So what do you call it? You call it continuous? Do you have to say the domain, like continuous on all?
Oh, discuss the continuity of the function. Can I evaluate a or an x coordinate at every single spot along this graph? Even though he has a hole here, he does have a filled in spot there. So this would be continuous on all rails. Add that to number 1.
so
You see that? Even though he has a hole in the middle, he does have this dot here, right? If that dot was not there, if this dot was not here, I could evaluate every place except 3, right? But the fact that he has a dot there means I can still plug in 3 and it still gives me a value, right? So he's continuous everywhere. What?
Okay, so the plus would be like if it's going towards the right, like it's going more towards positive or it's coming from the right.
What do we get for A?
Makes sense?
What's A on this one? Scroll up a little bit.
What's A?
0.
Luke, is
Zero.
2
It's coming in on the left and the right and
I
hitting
got
0 no
negative
matter what.
3.
Okay?
Should be
Alright.
positive 3 because it goes up.
Oh, you're right.
and then it's continuous all the way.
Yeah.
So, college,
Uh-huh.
the
What?
plus, would that be like it's going right or it's coming from the right? Like the little plus?
So Kyle, think of it as like,
Sign.
so you have your, say you have your line.
Don't ruin my clutch pedal.
I'm not ruining your clutch pedal. So you have this going
If
there,
it's 3 and
and
negative
this
3, it
going
still doesn't
here.
exist. 'cause
Okay.
they're not the same.
and say,
So the
so
top
you
would
take,
be
you
plus.
take your number, you find, so it's like, what if it's like,
5 plus.
5 plus, yeah. If it's plus, you go to your thing, say that's 5,
How is
And it's
C
going-
not
and then it's
3?
plus, so you're going plus, that's positive.
Lovely.
If it's negative, you're looking at the line going negative.
Lovely.
How is C not, because you're looking at y coordinates, not x coordinates, y coordinates.
That marker
So
sucks.
how's it not 1 then?
What do you call this?
Because the limit is what the y coordinate should be.
But the y coordinate is.
I know, but it's what it should be.
Okay.
That's what the y
So-
coordinate should be. Alright, I'm gonna shut this off for Jake, so this video is not like an hour long. Okay, goodbye.